In this video, we're going to cover 9 exercises related to Chapter 4. Steric strain is the result of. So in this question, you need to complete a sentence, and it's actually a definition of steric strain. You really asked for definition of steric strain. So A, free electron pairs needing more space than electrons in bonds. That's not steric strain. We use this phenomenon to explain bond angles in small molecules such as water, ammonia, and even that explanation has been questioned. But that's definitely not steric strain. That's electrostatic repulsion of free electrons. B. Bonds deviating from the ideal bond angle. That's the definition of angle strain, not steric strain. C. Bonds eclipsing each other. That's the definition of torsional strain. And finally, D. Atoms being too close to each other. That's steric strain. So D is the best answer here. Which of the following is a conformation of cyclobutane? Cycloalkanes have conformations that are associated with them, lowest energy conformations and sometimes some higher energy conformations that we can identify. And we name all those conformations with names specific to particular cycloalkane. So A, envelope, that's something that is associated with cyclopentane. Envelope is conformation of cyclopentane. B, planar. We can associate planar conformation with any cycloalkane. We can place any cycloalkane in planar conformation, but usually due to high angle and high torsional strain, that's extremely unstable conformation of a cycloalkane, except for cyclopropane, of course, where this is the only possible conformation. So for that reason, we would usually associate planar conformation with cyclopropane, as it is only reasonable in case of cyclopropane. Half chair, that's another of the cyclopentane conformations, not cyclobutane. And finally, Packard, that's conformation of cyclobutane. Which of the following is trans 1,2-dimethyl cyclohexane? There are several ways to answer this question. One is simply to make a model and then by inspection of model and comparing it with 4 possible choices, you can come up with correct answer. Another is to draw line formulas, including dash wedge bonds to indicate cis and trans isomers. First question is about 1,2-dimethyl cyclohexane, which means that 2 methyl groups have to be in 1,2 relation to each other, next to each other. That's 1,2. And when we consider 4 choices, A is actually 1,3, and so is D. So A and D are 1,3-dimethyl cyclohexanes, and we can right away eliminate them. Question is B and C. Which of them is correct answer? Which of them is trans? So when we draw a line formula, that's actually cyclohexane molecule looking at it from the top. Cyclohexane ring looking from the top. In trans isomer, one methyl group is above, the other one is below plane of the ring. In cis, both are above, as shown here on the right, or both are below the plane of the ring. And if we make a model, simply by looking at molecule from the top, if you make a model and then compare them with B and C, or if in the formulas B and C, you simply work with pen and paper and add hydrogens, then you will see that B is actually trans. One methyl group points up, one points down, while C is cis. Both methyl groups point up above the ring, above the plane of the ring. So even though we would typically assume that in case of trans compound, 2 methyl groups are further apart than cis, actually that's not necessarily the case. As you can see here, compound B, 2 methyl groups appear to be physically pretty close to each other, but they are actually trans to each other, because one is above, the other one is below plane of the ring. So correct answer is B. Rank the following compounds in the order of increasing stability, from the least stable to the most stable, based on the relative ring strain. So here we have 3-membered ring, ethyl cyclopropane, 4-membered ring, methyl cyclobutane, and 5-membered ring, cyclopentane. Based on the strain, cyclopropane exhibits the highest degree of strain. It exhibits very high torsional strain and very high angle strain. That means it's going to be the least stable of the three. So, or highest energy compound. So we list it first. That means that either A or D are correct answers. B and C cannot be correct answers. Next in the order of stability is cyclobutane. It still exhibits considerable angle strain, but much less than cyclopropane, and also considerable torsional strain. But in cyclobutane, you may recall, conformation is such that CH bonds on the neighboring carbons are in skew conformation to each other. They are not eclipsing and they are not staggered. They are somewhere in between. We call that skew conformation. So there is some torsional strain, but nothing like cyclopropane. So cyclobutane exhibits same types of strain as cyclopropane, torsional and angle, but to much lesser degree. So it is more stable. So that will be next in the order of stability. And finally, 3-cyclopentane. That will be the most stable. That means the correct answer is D. Cyclopentane exhibits relatively minimal angle strain. Bond angles are about 108, maybe a little bit less. And there is some torsional strain because some eclipsing interactions cannot be avoided in cyclopentane, but that's even less than in case of cyclobutane. So of the three, it is by far the most stable. So the order of stability is actually 1, 2, 3, or D. What is the most stable conformation that corresponds to the following formula? Here we have dimethyl cyclohexane and 4 conformations. Frequently, in case like this, a student may look at 4 possible conformations and select conformation with di-equatorial substituents. And that's because conformation with equatorial substituents is more stable compared to one with axial substituents. And that is true. But first, you need to make sure that conformation actually represents compound in question. So for that reason, first you need to establish what is the compound that you're looking at. And 2 methyl groups in this dimethyl cyclohexane are in 1,3 relationship to each other. So this is 1,3 dimethyl cyclohexane. Next, both methyl groups are above the plane of the ring. They are indicated by wedge bonds. They are connected to ring by wedge bonds. Both are above the plane of the ring. That means that compound is cis isomer of 1,3 dimethyl cyclohexane. So among the compounds A, B, C, D, we are looking only for cis isomer of 1,3 dimethyl cyclohexane. And so name each of these 4. First one would be actually 1,4 dimethyl cyclohexane. So obviously that cannot be an answer that we consider because it's conformation of 1,4 dimethyl cyclohexane. And same goes for choice B. It's 1,4 dimethyl cyclohexane. Now C is 1,3 dimethyl cyclohexane, and indeed it is cis, but it's diaxial. So that doesn't look like a good choice. It's right compound, but conformation doesn't look like a good choice. D, this is also 1,3 dimethyl cyclohexane, and it is cis, and it's di-equatorial. So that's the correct answer, because it's the conformation of the compound in question, and it's the conformation that has the largest number of equatorial substituents. So D is correct answer. Which type or types of strain is or are present in an eclipsing conformation of ethane? Ethane is the simplest organic compound that exhibits different conformations, and it has only 2 of them, eclipsing and staggered. Conversion of one conformation into the other is result of rotation or torsion around a single bond. And the only type of strain that is present is result of eclipsing of the bonds, and that's torsional strain. Draw a Newman projection that represents conformation of butane shown by the Sawhorse formula below. Conversion of Newman into Sawhorse is relatively easy and relatively simple. All that you do is, in this case you have Sawhorse projection, you erase the long angled bonds that connect the two carbon atoms, and then you have the two carbon atoms in form of letter Y or inverted letter Y. You redraw the back one, you draw a circle around it to indicate back carbon atom, and then you simply move the front atom to overlap with the back atom, so that we actually don't see the bond that we have erased. There is a video on YouTube, and it's under lectures, or actually under Organic Chemistry 1, and it shows how to convert one of these formulas into the other. Draw a conformation of butane that corresponds to the energy indicated on the diagram below. You should be familiar with conformational analysis of butane, and that includes conformational diagram of butane, so plot of energies as a result of dihedral angle. And you should be familiar with each of the extreme conformations. So each conformation corresponds to each absolute and relative maximum or minimum. Here we have relative minimum on the energy diagram, and that's the conformation that corresponds to 60 or also 300 degrees torsional angle. That conformation is called gauche. It's staggered conformation in which two metal groups are next to each other, or dihedral angle of 60. So angle between two metal groups, as you look at it in Newman projection, is 60 degrees. So here is representation on the right, Newman projection of gauche conformation. Draw a structure that corresponds to the most stable conformation of cis 1-isopropyl 3-methyl cyclohexane. There are several approaches to answering this question. One would be simply to make a model. So make a model of cyclohexane ring, and then place isopropyl group on carbon 1, methyl group on carbon 3, make sure they are on the same side of the ring, it's cis, and then from the model draw the conformation. Another one is to draw a six-membered ring, identify positions 1 and 3, as here, and then in each position draw methyl group and isopropyl. In position 1 isopropyl, 3 methyl, and make sure that they are on the same side of the ring. Most important point here is when dealing with conformations like these is to establish whether cis-1,3 disubstitute cyclohexane has conformations that are diaxial and diequatorial, as is the case here. That means that the most stable conformation will be diequatorial, and here are two diequatorial conformations that are shown, two drawings. Actually, it's one conformation, two different drawings, two different representations. We can do many other representations by simply rotating the ring. We can show in many other ways we can represent the same compound. Alternatively, other isomers, let's say cis-1 isopropyl 2-methyl cyclohexane, would have one axial and one equatorial substituent. And then, of course, the most stable conformation would have to be represented with one axial and one equatorial substituent. And then the larger substituent, isopropyl group, would have to be equatorial, smaller one axial. So you can do either from a model or from a drawing. You can figure out correct answer, but most important is to identify whether the most stable conformation in case of disubstitute cyclohexane is diequatorial or is it axial equatorial conformation, and in this case it's diequatorial. This completes chapter 4 exercises.